If your frame is delivered by a third-party hauler, you'll be required to unload the timbers. If you're fortunate enough to have Michael Michaela of Michaela Trucking deliver your home package, you'll find the process to be friendly, helpful, and professional. His home base is near the Brooks Yard and delivers many of their homes. Whoever your driver is, he or she will communicate with you as to scheduling and delivery costs. Michael called us from the road each day between New Hampshire and West Michigan to give us updates, and then again when he was within an hour of our property. The building site must be inspected for equipment and material location before delivery. There must be enough room on the site to unload the timber bundles, and also room to open the bundles and stage the pieces for assembly. You should choose a fairly flat, level area to set the timber bundles and panels, and bunk up the panels on some 2x4s, in addition to the bunks that are strapped to the bundles. If the site is muddy or wet, consider laying some sheet plastic, straw, or lumber wrap on the ground to prevent the timbers from getting dirty or wet. We want to emphasize the importance of adequate bunking under the bundles of timbers for air movement to keep the wood dry. 6 inches of space under the bundles is recommended. The timbers are covered in protective wrap, and the panels are shrink wrapped. You'll most likely use an all-terrain forklift, commonly known as a lull. These machines are available for rental from contractor rental companies. They're generally available on a daily, weekly, and monthly rental basis. Other methods include bucket forks on a loader or tractor. This works only on very level, stable ground with a large tractor. Take care to lift the bundles evenly and avoid damage. Take care to keep the material covered when not in use. Open the ends of the protective wrap and create a tent with scraps of wood. This allows air to circulate freely and keeps the water off. If you receive the panels at the same time as the frame, place the panels off to the side, away from vehicle traffic. The post will be set up first, so these can be set on the floor deck to be sorted out. The corner braces can go on the deck as well. Just make sure to place them in the middle of a timber bay so they don't interfere with temporary post bracing as you build. Shoulder beams and ties get used first, then joists, and finally rafters. Take time to familiarize yourself with the labels on the timbers and on the frame plan. Shoulder beams have an angled end cut and are load-bearing. They are likely to have mortises or notches for joists and rafters. Tie beams are cut square and are usually a size smaller than the shoulder beams. All like items are bundled together. Beams, ties, joists, rafters will all be in their own bundle. The pegs and screws for the frame and the foam and panel adhesive for the panels should be kept in a dry, protected location. In winter months, the foam and adhesive should be kept above freezing and warmed up just prior to use. Truck access to your building site is important. Most deliveries will require a tractor trailer. You'll be responsible for unloading the truck when it arrives. If possible, have the driver pull in or back into the site for unloading. If this is not possible, then plan on unloading the truck from the curb. If you think this will block traffic, be sure and notify the proper authorities in advance. We'll help you coordinate the delivery schedule, but it's up to you or your contractor to meet the truck and unload it in a timely manner. Your construction manual we will supply with your package will cover this unloading process in more detail, including how to place the different parts where they will be accessible in the order that you'll need them. The drawings that Brooks will send you with every package will clearly identify each part of your kit and where it belongs in the building. They use an alpha, A, B, C, etc., and numeric, 1, 2, 3, etc., grid of horizontal lines to locate the timbers in your frame. Combined with a vertical or elevation indicator, the location and alignment of any timber in your frame can be found. The elevation indicators are as follows. D1 stands for Deck 1, or the first floor. D2 is for Deck 2, the second floor. K1 means knee wall 1, and K2 equals knee wall 2. N1 is the lowest horizontal nailer, midway between floor and timber in barns. N2 is the next higher horizontal nailer. R1 stands for the highest ridge timber, and R2 is the next highest ridge timber on multi-level structures. The labels on the timbers are as follows. PO indicates a post, a vertical timber. BM is for beam. Beams have angled end cuts on the ends and are usually the deepest horizontal timbers. They may have joist or rafter pockets along their tops. TI is a tie beam, which usually joins a post at right angles to a beam and parallel to floor joists. This is how to read the labels on the actual posts, beams, and ties. The top of each post is labeled with elevation and grid locations like this one. Black paint on a timber surface means that side is on the outer side perimeter of the frame. On beams and ties, both ends will show the elevation and the two posts it will go between. The underlined post location indicates that this end goes to that post. So, tie beam D2, C2, D2, TI is located on elevation D2 and goes between posts C2 and D2. D2 is underlined, so that end goes to post D2, and it is a tie beam. Many people ask if you can have a walkout basement under a timber frame. Absolutely. It's actually quite common. The most unusual detail of the walkout section is the wall is built out of 2x10s. The thick wall framing is required to provide sufficient bearing for the timber frame and SIPs above. As before with the sill plate, the top plate is made to come flush with the exterior panel face and the sheathing of the wall below. Any timber posts located above the walkout or knee wall will need solid framing underneath in the form of a quadruple stud in order to provide solid bearing all the way to the foundation below. Be sure to install solid blocking under all post locations, the full width of the space between the joists and equal to the post depth. If a post lands on a joist, add blocking to both sides of the joist. Window and door headers will be specified on your plans, and where a post lands above a door or window, the header will probably be engineered lumber. You'll have the option of adding a 2x12 top plate and ripping it back flush with the outside face of the wall SIP panels. A note about windows and doors in these thicker walkout walls and knee walls. The door jambs will need to be ordered wider, and the windows will need wider jamb extensions for interior trim. Check with your millwork supplier and make sure they're aware of this wide wall condition before ordering the doors and windows. The pressure-treated sill plate or top plate of your knee wall is wider than what would be considered normal for conventional framing. They will specify a 2x12 pressure-treated sill plate. The detail shows that the sill extends past the outside face of the foundation about a ½ inch to 1 inch by design. This creates a drip edge and a clean transition off the foundation wall. You can also see from the detail that the purpose of the wide plate is to provide a shelf for the exterior structural insulated panels to rest on. The SIP panels sits on the sill flush to the exterior. This gap forms the wire chase. If you're using structural panels and installing wallboard or paneling yourself, then the posts will be flush with the rim joist. Using a 2x12 sill plate can simplify the initial layout of the deck, as it gives more room on top of the foundation wall. Attach the 2x12 pressure-treated plate to the foundation flush with the inside face of the concrete wall. The interior face of the timber posts posts will always align with the inside face of the concrete foundation wall. Refer to your architectural plan details. Floor joists are installed in the usual manner. It's very important that you take every step necessary to make the main floor as level, square, and true as you possibly can. The timber frame is pre-cut to exact dimensions and precise tolerances. If your work at this point in time is solid and the floor is level and square, you'll have no trouble erecting the frame, and the entire project will go exceptionally well. So take time to check your work, and it'll be time well spent. Use a builder's level, sometimes called an auto level, telescope level, or transit level, or a laser level to check the overall level condition of the floor framing. Check at the post locations especially. If you're plus or minus a quarter inch in elevation, you'll be in good shape. If you can get to plus or minus an eighth inch, you'll be in excellent shape, and no further trimming of the posts will be necessary. Check the sill plates before you start framing the floor, and check the floor framing before you install the subfloor plywood. You'll have many opportunities to make adjustments and shim any low spots. The timber frame posts are already cut to size and ready to install. They can be trimmed to compensate for out-of-level conditions if necessary. In this photo from the construction manual, the floor framing is just about complete. Note the metal tie straps that connect the floor system to the foundation are in place, but bent out of the way for now. Note that the strap tie extends through the pressure-treated sill and will be nailed to the rim board and timber posts to form a complete connection to the foundation. Here's a summary of the process of cutting your posts to length. If these adjustments are not done carefully, the fit of your timbers, braces, and rafters will not be accurate, getting worse as the frame gets higher. Number 1, at each post location, use your builder's level or laser level and find the measurement on your leveling rod. Write each measurement on your post location plan. You can also mark the floor at each post location. Number 2, assuming that your leveling rod has 0 on the floor, the largest measurement marked will be the lowest point on your floor deck and will be your longest post length. This will be the plan post length. All other post location lengths will be either this plan post length or shorter. Use 1/16 inch fractions for subtractions from plan post length. Number 3, cut extra material from bottom of post by cutting around the perimeter with a circular saw and finish with a handsaw. Make sure your circular saw is cutting squarely. Make sure the battery or power cord is disconnected during this process. Square it up with a square laid between the saw's plate and blade. Number 4, as you cut each post, place the base next to its post location on your floor deck. At the beginning, each post will have 2 2x4 braces to keep it upright. As the frame is assembled, the braces will be released and refastened several times to allow for the beams to be set and drawn together. At some point, many of these braces will become redundant and can be removed. After the posts, beams, ties, and braces for the first floor have been assembled, the outside corners should be plumbed and well braced with longer 2x4s. This will provide a rigid frame to work on as you go up and prevent any unintentional racking of the frame. The wall panels will provide permanent stability, but until then, bracing is required. Brace each outside corner down both sides. Each interior beam line requires 1 brace per line. The construction manual contains a list of tools, materials, and more detailed step-by-step instructions for this whole process of lifting and assembling beams and ties to the posts. Some frames will have timber floor joists and 2x6 tongue and groove decking. If that is true in your situation, the construction manual details the steps you'll need to follow. The craftsman at Brooks Post and Beam can talk that over with you also. Timber corner braces, also known as knee braces, are installed along with the beams and ties. They're held in place as the beams and ties are lowered down over the splines and guided into the mortises in the bottom of the beam and the side of the post. There are two types of braces, exterior and center. The exterior, or outside braces, are installed on the exterior walls. They are offset to the outside face, and the outer face will be flush to the exterior face of the post and beam or tie. The tenons on the ends are offset. Planed or smooth braces will not be chamfered or finished on the outer face. Center braces are exactly that, centered in the post and connecting beam. They're used for interior posts and in locations where both sides are visible. Planed or smooth center braces will be chamfered and finished on both sides. Rough sawn braces are not chamfered. The tenons are symmetrical on center braces. The photo above shows a center brace on the left and an exterior brace on the right. The exterior brace tenon is noticeably offset to one side. The braces are labeled with the brace run length, the horizontal distance from post to end of brace, and a C for center or X for exterior. The above braces are 36C and 36X. Standard brace sizes are 24, 30, and 36 inches. The frame plan and shop book should have the braces labeled such as 30X, 24C, etc. You can easily check the size by measuring the distance across from the face of the post to the mortise. The brace run will be an inch or two past the end of the mortise. A note about corner braces. Where two braces converge at the same height on the post, the brace tenons must be cut back to just under 3 inches. Otherwise, they will interfere with each other in the mortise. Braces should not be drilled and pegged until the entire frame on that level is in place and temporarily braced plumb and square. The braces can be left loose or floating in the mortises while the frame is assembled and plumbed up with the 2x4 braces. This way, they will not interfere in case the frame needs to be racked or adjusted for plumb and square. Once the frame section is nice and square, the braces can be drilled and pegged to lock everything in place. The unique and patented Brooks brace clamp that will be supplied in your kit is used to position the braces in place for drilling and pegging. The holes should be pre-drilled in the post and beam through the mortises. The tenons on the brace are not pre-drilled. This allows for final adjustments. The eye of the brace clamp goes on the nearest peg at the post beam joint as shown. Squeeze the handle to tighten the brace into place. The brace mortise has a bit of play, so it can be perfectly aligned, checking the ends of the brace for a nice fit. Using the supplied 31/32 inch drill bit, carefully drill through the pre-drilled post or beam hole and drill out the brace tenon. The drill bit is intentionally undersized so that the 1-inch peg fits nice and snug. Use the pre-drilled hole to align the bit, and don't force it. Some people find it's easier to start the drill in reverse to center the bit. If you think it's running off, stop and try drilling from the opposite side. Finally, drive the pegs into place. The rafters have been sitting on site for the duration of the frame raising and probably soaking up any rain or moisture. The plates and ridge beams have been up and exposed to rain as well. It always seems to rain at the worst time, doesn't it? All that moisture affects the sizes of the timbers, and each one is different. We precision cut the mortises and rafters, but we can't control Mother Nature once they leave our shop. So, we recommend that you take a few minutes and measure the width of the rafter pockets cut into the plate and ridge, and compare them to the ends of the rafters. If the pocket is less than 6 inches, or the rafter end is more than 5 15/16, take a few minutes to fix that. Use a belt sander, planer or block plane, or a sharp chisel, and carefully shave back the sides of the rafter that fit into the mortise pocket. The pocket is 1 or 1.5 inches deep, so we like to simply use a sharp chisel and carefully taper the sides back a bit so that they fit easier. Make sure to trim the depth of the rafter so you don't cut too much. You are only trimming the sides of the rafter, not the top or bottom, and only the portion that is concealed in the mortise pocket. It's far better to do this in advance, or at least stay ahead of the hoisting crew, than to hold everything up to check and trim each rafter as you go. One more note on setting and fitting rafters. If one or several rafters are giving you trouble and the crane is waiting and people are standing around, just set the rafter in place or right next to it and move on. The rafter will stay put. It won't slide or fall off. You can come back to it later and fuss with it. Use a pry bar to pry it out of the mortise pocket and trim it as described above. In this photo, the rafter is resting next to the mortise pocket while the sides get a trim with a chisel. The 8-inch screws in the top are sticking out for a handle and will be used to pull the trimmed rafter into place. Once the second floor is decked over and the ridge beams are set, it's time to install the rafters. If the rafters are small enough and you have enough manpower, you can simply muscle them into place. For larger rafters, you will need to set them with a crane or with a forklift equipped with an extension boom. Setting the rafters is an exciting step. The frame is almost complete, and it's looking great. You should probably have extra help and extra equipment on hand to set these long timbers into place. They will be set at the highest part of the frame, often working on tall ladders. They are usually the longest timbers we have, and being the last ones to go up, they've been sitting on the ground for the longest time. But it's okay. We have some tips and techniques to help this part go as smoothly as possible. Follow these steps, and you should be in great shape. Note that barn rafters have a bird's mouth notch and are set on top of the beam. House frame rafters are set into mortises in the beams. In either case, the technique is the same. You should set rafters in pairs opposing each other at the ends and posts wherever possible. Never set one entire side before the other. This will put unnecessary weight and strain on the ridge beam and make it more difficult to get the other rafters into place. Get the gables and post rafters set first. Setting the rafters in opposite pairs keeps the posts and ridge nice and straight and equalizes the weight distribution. The rafters should be rigged with 2 straps, an 8-foot and a 12-foot. We supply these in our toolbox, arranged so that the rafters hang at an angle slightly steeper than the roof. This allows the rafter tail to be set into the pocket first. Then the top is guided down into place of the ridge beam. It's important to get the rigging arrangement right, so it can be easily and quickly repeated once everything is moving along. We test fit the straps on the first rafter until we find the right distance from each end. We take measurements and mark each rafter in advance, and then we tap in nails to prevent the straps from sliding out of position as they are raised and swung into place. Set the rafters in place and pull the top into position, even with the ridge. Screw only the top, using 2 8-inch screws. Leave the bottom alone for now. The rafters are secured in place with 8-inch screws at the ridge and 6-inch screws at the plate, included with the frame package. If there's a gap at the top or bottom, the ridge beam and lower shoulder beam can be winched together to close the gap. After all or most of the rafters are in place and top fastened, you can come back through and snug up the lower ends. Ratchet straps are supplied just for this purpose. The top tip of the rafters should be even with the top edge of the beam. If they look nice and even like this picture, you can screw them down, but chances are they won't. More than likely, they look like this. Note the space from the rafter tip to the edge of the beam. That's where the straps come in, and big hammers. Liberal use of a large hammer is expected and encouraged. Remember to use the softer face on visible surfaces. Brooks supplies lengths of 4x6 cut at an angle, which they refer to as triangles. These are installed on the rafter plate, or plate beam, between each rafter to close off any gap that might be visible where the roof and wall panels join together. Simply cut the pieces to fit between each rafter and nail or screw as shown. Some homes will have a 2x8 or 2x10 cavity or hollow floor system over joists and beams, or just over beams with no timber joists. This picture shows joists installed over timbers. In most cases, the 2x floor joists will be laid over furring strips equal to the thickness of the ceiling material, plus a little bit. The ceiling finish will be drywall, so 5/8-inch furring strips were installed on top of the beams. If your ceiling is 1/2-inch drywall, for example, the furring strip can be 5/8 inches OSB. The actual thickness is 19/32. This allows room for the drywall to be slid in between the exposed beam below and the joist above. Similarly, if your ceiling is 3/4-inch pine, the furring strips will be 7/8 of an inch. This creates a nice finished look without having to tape or cover the edges with molding, and allows you to install these weather-sensitive materials after the building is dried in. If you are installing a tongue and groove deck on your floor joists, you'll need to install wiring for lights or fans that will be in the ceiling below. A groove or slot will need to be cut in the top of the joists and beams to route the wire from the fixture location to the switch location. It's much easier to cut the wire channel before installing the joist on the floor or on sawhorses. We can cut these channels in advance when we cut your frame, but it also can be done on site. Now's the time to think about ceiling fixtures that'll be hung from joists, rafters, and beams. A very common fixture is a ceiling fan hung from the main ridge beam over the great room. Other common fixture locations are light fixtures above the dining table and ceiling fixtures hung to illuminate the hallway. All of these locations should be mapped out in advance and coordinated with your electrician. You'll need to run some of these wires prior to installing the wall and roof panels if you're not setting the panels off on first strips. So you need to determine not only where the fixtures are located, but also how the wires are run and where they will terminate. We have found the best course of action is to run the wires along the top of the ridge beam, centered on the beam, to the outside wall, then down the outside top face of a gable rafter to a corner post, down the outer edge of the post, and into the basement. Take care to keep the wires as close as possible to the top or outer edge of the beam and post to prevent accidental damage from a screw while installing the panels later on. From there, the wires are pulled horizontally along the top of the rim board wire chase, through the rim, and into a junction box. The wires on the ridge beam should be run on the center of the beam. while those on the side plates or post should be held to the top edge and secured in place with Romex staples. Brooks can supply light bars or light blocks for locations which fall between joists or rafters. These are supplied loose and a few inches oversized. They are to be cut to length and installed on site after the joists and decking are installed. They are pre-drilled for a fixture box and have a groove cut into the top side for a wire. They're a perfect fit for hanging lights or fans with standard size canopies. As with the direct mount fixtures, the wires must be run on top of the beams or joists ahead of time. The wire is run to the desired location, and a length of wire is left hanging out the side where the light bar will be located. We can supply similar blocks or bars with a bevel top surface for installation on a sloped ceiling between rafters. You should let us know in advance how many of each type you will need, so we can include the correct number with your frame package.